Good morning students. Today 6th April chapter 1 continue. See first lecture of today. Example 1.13. What is given in data? Positive charge point in nucleus. It is atomic model, okay, suggested by a scientist. Positive charge point in nucleus having charge Z means positive charge is in a very tiny region called nucleus having charge Zt is surrounded by a uniform density of negative charge up to radius capital R. Atom as a whole is neutral. Then find electric field at distance small r from nucleus. Now see, understand what is question. Positive charge point nucleus. It is positively charged point nucleus. Okay, positive charge Ze. Okay, surrounded by negative charge up to radius r having uniform negative charge density. Surrounded by negative charge up to radius r. And you are also given atom is neutral. So atom as a whole is neutral. Positive charge of point nucleus is Ze. Then to make it neutral, what is negative charge surrounded by it? Minus Ze. Ze minus Ze. Total charge will be 0. Atom as a whole neutral. Okay. Negative charge surrounded by it minus Ze. So what is its surface charge density? Surface charge density of negative charge. Its surface charge density sigma is equal to charge upon volume. Charge upon volume minus Ze 4 by 3 pi r cube up to radius r. Clear? It is data given. Now you have to find electric field due to this atomic model. Now we will find electric field at 3 points: outside, inside and on surface. Outside, inside and on surface. First of all we will find outside, that is R greater than R. That is R greater than R. We know how to apply Gauss law. Okay, you have to consider one Gaussian surface at distance R greater than R. Okay, from figure it is clear. Charge enclosed by this Gaussian surface is total charge on atom, and atom as a whole is neutral. So total charge enclosed by this Gaussian surface is 0. So electric field is also 0. R greater than R. In this case, the total charge enclosed by Gaussian surface is 0. Since atom is neutral, so electric field is 0 for R greater than R. At any point outside, electric field is 0. Now second case, for R less than R, that is inside. Okay, see, draw figure. Positive charge, nucleus, surrounded by negative charge, electron, up to radius R, capital R. Now as you have to find electric field inside, take a point at distance small r, which is less than R. Assume Gaussian surface, a sphere of radius small r, a sphere of radius small r. Clear? Okay, now what is method? We know. First of all, find electric flux with the help of this equation. Okay, electric flux enclosed by Gaussian surface, phi is equal to integration E dot ds is equal to E ds cos 0. Hello, cos 0. It is repeated. Why cos 0? Angle between E and ds is 0. Due to uniform charge distribution, electric field is in radial direction at each and every element. Area vector is perpendicular outside. So for each and every element on Gaussian surface, E is parallel to ds. Angle between them will be 0. Cos 0, 1. So phi is equal to E integration ds. Again E for uniform charge distribution at given distance. Electric field is constant. Integration ds is 4 pi r square. Equation number 1. Flux with the help of first equation. Now with the help of Gauss law. See, what is equation of flux? Flux is equal to charge enclosed by Gaussian surface upon epsilon 0. charge enclosed by Gaussian surface upon epsilon 0. It is Gaussian surface with this yellow chalk, with this yellow color. Okay, in this Gaussian surface we can see clearly from figure that this Gaussian surface encloses total positive charge of nucleus. But is this Gaussian surface enclosing all negative charge? No. Okay, negative charge is enclosed up to radius small r. Up to radius small r. So the charge enclosed by Gaussian surface is total positive charge, and negative charge within the sphere of radius r. Negative charge within the sphere of radius r. So how to find total charge? Total charge sigma q is equal to Ze. Ze, total positive charge of nucleus, plus rho dV. What is rho dV? Rho dV is charge enclosed by sphere of radius small r. Rho dV. Now put value. See, sigma q is equal to Ze minus. Why minus? Because rho is equal to minus Ze 4 by 3 pi r cube. What is surface charge density of negative charge? Minus Ze upon 4 by 3 pi r cube. What is volume of sphere of radius r? 4 by 3 pi r cube. 4 by 3 pi, 4 by 3 pi cut. Sigma q is equal to Ze minus Ze r cube upon r cube. Clear? So it is charge enclosed by this Gaussian surface. Now flux phi is equal to sigma q upon epsilon 0 is equal to Ze common. Ze common upon epsilon 0. 1 minus r cube upon r cube. Now compare these two equations. Equation number 1 and equation number 2. Equation 1, E 4 pi r square. Equation 2, Ze upon epsilon 0, 1 minus r cube upon capital R cube. You have to find E 4 pi r square on another side. Then see, last step. It is last step. Okay, E is equal to 4 pi epsilon 0. On second side it is in denominator. 4 pi epsilon 0. Epsilon 0. This r square you have to multiply in bracket. So it is 1 upon r square minus r cube upon r square. Then it is only r upon r cube. Clear? So it is electric field inside. It is electric field inside atom. Now, third one and last point. What is electric field on surface? What is electric field on surface? For electric field on surface, you have to put small r is equal to capital R. If you put this data for electric field inside or for electric field outside, you will get the same result, and that result is electric field is 0. Electric field is 0. So for surface, electric field is 0. So it is one question again based on Gauss law. Okay, how to find electric field due to such charge distribution? Pause your video, write down from board, make notes, send notes on my WhatsApp number. For other school students, send notes to your respective subject teachers. Thank you. Good morning, students. Lecture 2, some exercise questions based on Gauss law and deflection. See, exercise 1.14. What is question? You are given two charged plates placed parallel to each other, forming uniform electric field. Three charged particles are projected in this region of electric field. You are given figure. What is your question? You have to find sign of charges 1, 2 and 3, and second, which particle has maximum charge to mass ratio. See, sign of charges easy. We know that negative charges are attracted towards positive plate and negative charges are attracted towards positive plate while positive charges are attracted towards negative plate. See, from figure we can say this first particle, it is attracted towards positive plate, means this first particle is negatively charged. It is negatively charged. This second particle, see, it is also deflected towards positive plate, means it is also negatively charged. It is also negatively charged. While this third charge, this third particle is deflected towards negative plate, means it is positive charge. Means it is positively charged. Clear? Now what about second question? Okay, which particle has Q upon M ratio maximum? See, in one of the exercise question, we have obtained one equation of deflection. Okay, y is equal to Q E L square upon 2m Vx square. Q E L square upon 2m Vx square. See, from this equation, this Q upon M depends on deflection. If we have more deflection, Q upon M ratio is more. Less deflection, Q upon M ratio is less. From figure we can say for this third particle deflection is maximum. For this third particle deflection is maximum. So for this third particle Q upon M ratio is also maximum. So which particle has Q upon M ratio maximum? Third particle, because its deflection is more. Its deflection is more. Clear? It is exercise 1.14. Next question is again how to find the Q upon M ratio is maximum. We know this equation, y is equal to Q E L square upon 2m Vx square. Q upon M is directly proportional to y. So if y is more, Q upon M ratio is also more. From figure we can say for this third charge deflection is maximum. So for this third charge Q upon M ratio is also maximum. Clear? Now next question, exercise 1.15. You are given uniform electric field 3 into 10 raised to 3 I caret Newton per coulomb. I caret, it means electric field is in positive x direction. You have to find flux passing from a square having side 10 cm parallel to yz. See, first of all draw figure x, y, z. Square of 10 cm parallel to yz means it is parallel to yz. Now electric field is in x direction. Electric field, it is in x direction. This square is in yz plane. Its area vector always perpendicular outside. Perpendicular outside means in this direction, it is S. So from figure it is clear, E and S, they are parallel to each other. Okay, then how to find flux? We know equation of flux. Phi is equal to E S cos theta, cos 0, y 0 from figure. Okay, S means area. Area is equal to 0.1 whole square. Square of 10 centimeter. 10 centimeter means 0.1 meter. 0.1 into 0.1, it is 0.01. Calculate, your answer is 30 Newton per coulomb meter square. What is flux passing from this square plate? 30 Newton per coulomb meter square. Now what is question B? If normal to plane makes 60 degree with x-axis, 60 degree with x-axis means this plane is rotated. This plane is rotated. Normal to plane means area vector. Normal to plane means area vector. Area vector makes 60 degree with x-axis means electric field. Then what is change in equation? Phi is equal to Es cos 60. Es cos 60. E 3 into 10 raised to 3. S 0.01. Cos 60 is 1 by 2. So your answer is 15 Newton per coulomb meter square. Clear? So it is exercise question number 1.15. Next, exercise question number 1.16. It is related to 1.15 with one change. You are given one cube. Faces parallel to coordinate system. Then you have to find what is flux passing from this cube. See, x, y, z, all faces are parallel to coordinate system. Then you have to find electric field. Now see, as electric field is uniform, and we have discussed in example 1.11 when form some symmetrical objects, when electric field is uniform, numbers of electric field lines centering is equal to numbers of electric field lines leaving. It means total flux is equal to 0. It means total flux is equal to 0. So whenever you are given symmetrical object and electric field is uniform, total flux passing from the cube is 0. Clear? Now last question, exercise 1.17. You are given flux. Okay, flux passing from a surface is 8 into 10 raised to 3 Newton per Coulomb. You have to find what is charge enclosed by surface. Charge enclosed by surface with the help of Gauss law. Phi is equal to sigma q upon epsilon 0. Then sigma q is equal to phi epsilon 0. You can easily calculate. Okay, phi is equal to 8 into 10 raised to 3. Epsilon 0 is equal to 8.85 into 10 raised to minus 12. You know that. Okay, it is your homework. You have to just calculate. Okay. What is second question? If phi is equal to 0 means flux is equal to 0. Could you conclude that there were no charges? Is it possible that flux phi is equal to 0 means that Gaussian surface encloses no charge? No, it is wrong. It is wrong. Phi is equal to sigma q upon epsilon 0. Sigma q means total charge, and total charge is 0 when we have equal amount of positive charge and negative charge. So flux is 0 if surface encloses equal number of positive charge and negative charge. Clear? So these are some questions from exercise. Pause your video, write down in your notebook, send notes on my WhatsApp number. For other school students, send notes to your respective subject teachers. Thank you. Okay students, lecture 3, one more question from exercise 1.18. See, you are given one square plane and a charge, a point charge 10 microcoulomb is located at 5 centimeter above. What is your question? You have to find flux passing from this square plane, See, find magnitude of flux passing from this square plane. How to find flux? What is equation of flux? Flux is equal to sigma q upon epsilon 0, where sigma q is charge enclosed by Gaussian surface. Here this charge is not enclosed. How to enclose this charge? First of all, we have to enclose this charge with the help of another 5 plates. Forming one cube. Clear? Okay. So now see, this charge is enclosed by this cube. Cube means 6 faces. So flux passing from cube means 6 faces is equal to q upon epsilon 0, because now this charge is enclosed by cube. So flux phi is equal to q upon epsilon 0. But what is your question? You have to find flux passing from this square only, means only one face. So what is flux passing from one face means square is equal to divided by 6. divided by 6. So it is q upon 6 epsilon 0. See, this charge q is enclosed by cube. Cube means 6 faces. So for total 6 faces, flux is q upon epsilon 0. Then what is flux for only one face? Yes, it is divided by 6. So for one phase, flux is q upon 6 epsilon 0. Q 10 microcoulomb, 10 into 10 raised to minus 6. 6, that is 6. Epsilon 0, 8 into 8, 8.5 into 10 raised to minus 12. Okay, you can easily calculate this. Clear? Now, next question, exercise 1.20. Flux is equal to minus 1.0 into 10 raised to 3 Newton meter square per coulomb from a Gaussian surface of sphere having radius 10 centimeter. First question is, what is charge enclosed by Gaussian surface? See, it is very easy. Flux phi is equal to sigma q upon epsilon 0. That is, sigma q is equal to phi epsilon 0. Phi minus 1.0 into 10 raised to 3. Epsilon 0, 8.85 into 10 raised to minus 12. You can easily calculate. Okay, as your homework. What is question B? If the radius of Gaussian surface were double, then what is flux passing from this Gaussian surface? See, what is equation of flux? Flux phi is equal to sigma q upon epsilon 0. This flux depends on charge enclosed by Gaussian surface. It does not depend on its size. So if its size is double of its size is halved, flux will remain same. Flux will remain same. Clear? So note this point. Phi depends on charge enclosed by Gaussian surface. It does not depend on size of the body. It does not depend on size of the body. Next question is exercise 1.25. What is exercise 1.25? It is Millikan's oil drop experiment. Millikan's oil drop experiment is used to find charge on drop. What is charge on drop? How? See, oil drop having 12 excess electron held stationary with uniform electric field E is equal to 2.55 into 10 raised to 4 meter per coulomb. Density of oil is 1.26 gram per centimeter cube. You have to estimate radius of drop. How to estimate radius of drop? See, oil drop. Okay, if we have one drop of oil, first force acting on it due to its mass, gravitational force, that is always in vertically downward direction. But you are given oil drop having 12 excess electrons held stationary. Held stationary, it means total force acting on it must be 0. So if one gravitational force is acting in downward direction, there should be one more force and acting in upward direction. We know that this oil drop having 12 excess electron means charge, and on this charge in electric field force acting is QE. Force acting is QE. So on oil drop, two forces are acting. One gravitational force in downward direction, one electric force in vertically upward direction. For stationary oil drop, sigma f is equal to 0. So mg is equal to QE. M, we have to find the radius. Then how to introduce radius? Mass is equal to rho into V. Okay, what is definition of density? Density rho is equal to mass upon volume. Then mass is equal to rho into V. G is equal to Q. Charge on oil drop. Oil drop has 12 excess electron. What is charge on one electron? E. So charge on it 12E. It is T. Rho V is equal to 4 by 3 pi r cube, because oil drop, a sphere of radius r. So it is 4 by 3 pi r cube. G is equal to 12 ET. 4 into 3. Okay, make r cube as subject. So r cube is equal to Q E upon rho by G. Make r as subject. R is equal to this whole term is to 1 by 3. Each and every data is given. 9. E 1.6 into 10 raised to minus 19. Capital E 2.55 into 10 raised to 4. Rho 1.26 gram per centimeter cube. Students, gram per centimeter cube. You have to convert in kg per meter cube. How to convert? We have studied in 11. Okay. Pi. You know what is value of pi? G. That is 9.8. Put each and every value. Calculate. You will get your answer. Clear? So these are some questions from exercise. Write down in your notebook, send me notes, send me answers on my WhatsApp number. For other school students, send to your respective subject teachers. Thank you.